Okay, so now let's move to the final method in LU method. Okay, so we call as Thomas algorithm method. Okay, so for this method is actually suitable to be used to solve a large system of linear equation. Okay, so when we talk about large system means that the size of matrix will be bigger than what you have solved previously. But then for your practice, okay, and for our scope, okay, so normally it will be up to 3 by 3 or 4 by 4 matrix. Okay, so we just would like to introduce how actually that method works. Okay, so in this method, okay, so there's condition that the given matrix A must be a tridiagonal matrix. Okay, so let's recall back. Okay, so what is mean by tridiagonal matrix? Okay, so when we talk about tridiagonal matrix, actually, okay, so it's a matrix, okay, where we have a non-zero element, okay, on the main diagonal. So this is actually the main diagonal. Okay, and then we also have non-zero element, okay, on the first diagonal below the main one and also above the main diagonal. Okay, so means that we have only we should only have a non-zero element in this particular color. Okay, so if the question asks you to solve using Thomas algorithm method, you should be able to get this trigonometric first. Okay, so let's say if the given trigonometric is not as what you should have, okay, so you can try to arrange rows in matrix A. Okay, but then please remember, okay, any changes in A should also apply in vector B. Okay, so normally, okay, so student forget about this part. Okay, so please make sure that when you rearrange or swap the rows, okay, so to get trigonal matrix, you apply the same changes on vector B2, okay, to ensure that you actually get the final answer, the correct final answer. Okay, so that is how this method works actually. Okay, so that is the condition. Okay, so the next one is on how can you solve it using this method. Okay, so I would say that this method will be more simple compared to others. Okay, so the formula will be given. Okay, so the formula will be given like this one. Okay, so this one can also be in this table. Okay, so if you see actually, okay, so for this part is actually come from the first 3 row is actually come from your matrix A. Okay, and then this come from your matrix B. Okay, so it's given actually. Okay, and then this one is actually for L. This one for the U, means that lower triangular matrix. This one is for U, okay, which is upper triangular matrix. Okay, so this one is actually for LY, and this one is actually for UX. Okay, so instead of we solve it like what we had in general procedure of LU method, okay, so for Thomas algorithm, we will strictly use this table. So that will be, I would say that will be easy. Okay, so if you use this table, okay, because all the info or all the formulas are given in your exam, so you can just straight away use the table, but be particular, be careful with the calculation. Okay, so let's see one example here. Okay, so let's see, we have the first one. Okay, so the question asks you to perform Thomas algorithm method to solve the following system of linear equation. So if we write into metric form, you will definitely get into this part. 2910 0194 sorry for my mistake. So for this one should be 2100. So this is the element for matrix A. Okay, so this is the element for matrix X 4, and then we have the element for matrix B will be like this. Okay, so we know, okay, so if you see, so this one will be the main diagonal, right? Okay, so we have a 0 element for this one. Okay, so you will definitely have to change, okay, have to interchange the row. Okay, so for this question, so the suitable step that you should apply to get tridiagonal matrix. Okay, because if you like to perform Thomas algorithm, you should get trigonal matrix first. Okay, so we should swap R4 with R1. Okay, so for this one, okay, so the new what should I say, the new form of matrix A will be like this. Okay, so the changes only happen in row 4 and row 1 only. So all the other rows should be maintained. So we have 0, 0, 3, 4 here. Okay, so like I said, okay, the changes should be applied into matrix B also. So we know that the changes happen on row 4 and row 1. So we have 9 here, 6, 8, 8 here. Okay, so make sure that you change for this part too. Okay, if not, it will lead to a wrong answer. Okay, so now check back, okay, whether it's actually satisfied the condition of trigonal matrix or not. Okay, so this is the main diagonal, and this is the first diagonal after the main diagonal, and also for this part. Okay, so if you see from here, okay, so we have the trigonal matrix after we apply this one. Okay, so if we successfully get trigonal matrix, so we can calculate it. Okay, we can solve it using Thomas algorithm method. So now let's form the table. Okay, so let's form the table. Okay, so let's refer to this one. Okay, so for this one, okay, so let's create the table. Okay, so we have the iteration here. It's not iteration, it's like the identical. Okay, so for this part, so we have di first. So d is the element on the main diagonal. Okay, so just now we have 2, 9, 9, 4. Okay, so this is come from this one. Okay, from this one. Okay, so let's put it into the table. The next one is the element for E. Okay, so the element for E, okay, so it started with I equal to 1 based on the formula. Okay, so be careful with this one. Okay, so E1 is actually for this part. Okay, so this is okay, let me change the color. So this is E1, E2, and then E3. Okay, so the element here should be 1, 1, 4, and then there's no element here. Okay, so the next one will be the values of C, I. Okay, so it started with I equal to 2 here. So there's no element here. So if we see from here, okay, so C is actually for this part. So this one will be C2, C3, and C4. So we put it into the table. So this one should be 2, 1, 3. Okay, so we will solve. The next one is for BI. So BI will be the element that given. Okay, so for this one should be 9, 6, 8, 8. Okay, so the next one is to figure out the values of alpha I. So based on here, we know that alpha 1 should equal to D1. Okay, so this one will be the first value of alpha here because it's equal to D1. Okay, so the next values, you have to use this formula. Okay, so if you notice in this formula, okay, let me zoom in. Okay, so for this one, you need the values of okay, for the next alpha, you need the values of previous beta. So means that you have to figure out the values of beta first. So okay, so beta I will equal to EI divided by alpha I. So we have figured out the alpha, the first alpha, right? So divided by this one. So you should get here is 1 over 2. Okay, so you should use this value to get this part. Okay, so to apply or to use this formula. Okay, so the next values for this one should be 8. Okay, so same goes. Okay, to get this value, you have to figure out the values of beta first. So this one is 1 over 8. Okay, so 71 over 8 here. So this one will be 32 over 71. Okay, so for this part, okay, the last one will be here, 188 divided by 71. No values for this part. Okay, so that is the ending for beta I. Okay, so the next last two values is W and X. Okay, so WI and then XI. Okay, so W1 will be B1 divided by alpha 1. So you got all the values. So here will be 9/2. Okay, so from here, okay, so you will use the values of this one. Okay, so like for this one, you need to get the correct values for this one to be able to get the correct values for the rest of W. Okay, so you get the values, this one, 67/71, 367 divided by 188 here. Okay, so that is for W. Okay, and then the last one, okay, to get XI. Okay, and then you see this relation, so you should be able to get the values in this part first until you get to this one. Okay, it's backward substitution, right? Okay, so for this part, okay, so xn is equal to wn, so it's actually come from this value. So this one will be 367.1882. Okay, so if you are able to get these values, you will definitely get the rest of the values for x. So this one will be 3/47, negative 18/47, 441 divided by 94 here. Okay, so this is actually these values. This is actually the final values. Okay, because we are looking for the values of x, right? So we have x1 is equal to 441 divided by 64 here. X2 is equal to negative 18 divided by 47. X3 is equal to 3/47. And the last one will be 367 divided by 188. Okay, so the last part will be the checking part. Okay, so it's similar. Okay, so you can replace back, okay, all the values of x1, okay, into this equation. You will definitely get approaching this answer. Okay, so you can try by your own for the next example. Okay, so I will share the answer. Okay, so maybe I can share just, okay, I can just give you the answer so you can try by your own for this example. Okay, so the answer for this part, okay, for x will be 2 3 negative 2 1 here. So this is the answer for x. Okay, so I would like you to go through step by step, okay, in constructing the table. I know it seems easy, but then if you make some small mistake, okay, it will lead to a wrong answer. Okay, so you can practice by your own. Okay, so we have covered for all methods in LU method. Okay, so in the next video we will move to the iteration method. Okay, so that's all for this video. Thank you.